Hi, in this video, I'll be talking about something called the module syntax pattern in JavaScript. So, unlike some other languages, JavaScript has no distinction between public and private methods and variables. So that can make things a little tricky when you're trying to, when a project grows to a certain size and you want to make sure your variable names don't collide with each other. You want to compartmentalize your variables and methods into modules. In some other more strictly object-oriented languages like Java, they have public and private methods and variables, which make this a little easier. But JavaScript, it doesn't have that built in, but luckily there's a workaround we can do to sort of emulate that behavior by leveraging some tricks in the syntax. So that's what I'm going to be showing you today. So just to start off, let me give an example of why we might want to use this pattern. So let's imagine we have a module called counter. And what this does is it keeps track of a count and allows us to increment that count. So you see, this is a simple JavaScript object. It has a count, has a count property and an increment property, which is a function. And we can use the increment function to add 1 to this count variable, basically. And we can see how this works here. Oh, sorry. I'll say console.log counter.count, and we'll run this. And we can see we get 0 here, as we should, because it's 0. So now we'll say counter.increment, and then do the same thing right after. So we get 0, 1, because this line of code added 1 to the count, and then we logged it again, and we got 1. So this is working pretty fine so far. But now let's see what happens if we do this. We'd say counter.count equals some improper value, which wouldn't make sense. We wouldn't want count to be a negative value, but right here, in the way this is currently set up, we're able to just go right in and change count to anything we want. And that's dangerous because we don't want to accidentally be able to change this. We want counts to only be able to be modified through this increment function. And you can see, we log this again, and it has this weird value we just randomly assigned. So yeah, this is the behavior we're trying to avoid using the module pattern. So let's now go in and see how we can rewrite this to protect the count variable from modification. So before we get into the module syntax pattern, I want to explain something called anonymous functions. So you may be familiar with writing functions like this using the function keyword. This is probably the simplest way of declaring a function in JavaScript. You use the keyword function followed by the name, followed by a list of parameters, and then your function code in that code block. But we can also write the same function like this. Const a. So in the first case, it's function a. There's no equal sign. But we can say const a equals function like that. So they look similar, but the key takeaway here is, in this case, we're treating a as a variable. You know, this is the same thing as if we're going to write like const a equals 2, for example. Syntactically, the key takeaway here is that in this case, this function value is sort of stands on its own as an object. So it's basically a different way of assigning a function, and this is called an anonymous function when you have a function without a name, basically. So it's another way of assigning functions in JavaScript, but the reason we can do this is because in JavaScript, functions are called first-class functions, which means the JavaScript engine treats functions as objects, the same way that numbers and strings are treated. So that's why we can say const A equals 2, const B equals my string, any string, const C equals function. And we can create a function called C by assigning it to a variable like any other value. And so it's a slightly different way of creating a function rather than using this function keyword, which is slightly limited. And you'll see why in a moment why this is important. So going back to the original problem, we want to protect this count variable so we can only access it in a predictable and managed way that we've decided through this increment function. So, okay. So now that we know about anonymous functions, I'm going to explain something called an IIFE. It is IIFE. This stands for immediately invoked function expression. So in this case, the function expression refers to the anonymous function we just went over. When you write a function, an anonymous function like this, just standing on its own, this is a function expression, and it's basically the same way as if we just stuck the number 2 somewhere in our code, or a string somewhere randomly in our code. It doesn't do anything on its own, but it's regarded as an expression by JavaScript. So a function expression, simply a function standing on its own that can be treated as an expression by the JavaScript engine. So we can do something very interesting with these. So we take a function expression. At first I want to pedal back a little bit here and just so I'm gonna show what happens when we assign an anonymous function to a variable like this. So and let's assign this function and then call it. So we'll say const A equals function console.log 2. So let's check this out. If we assign this function to A and now we console.log A, what happens when we run this? We'll see it prints out the value of A, which is itself a function. So we're not calling this function. A is a function itself, and we're printing out the function itself. So that's why we can see the code. But if we go in here and we add double parentheses to indicate we're invoking this function, now let's try running this. We get 2, right? Well, actually, yeah, it would make more sense to say we return 2. And now we are logging the result of running the function A. We get 2. Okay. So now let's see what happens when we. Okay, so we have A, which is a function expression. So now we're going to create an IIFE. We'll say const B equals. We'll write something similar, except this time. So let's write the same thing. This time we're going to wrap the function in parentheses. and then put a set of double parentheses right after that. So it's a little strange to look at syntactically. It's a lot of parentheses involved, but just pay attention to this. It's a function expression wrapped in I'll type it again. You wrap a function expression in parentheses and then put another set of parentheses after, as if you're immediately calling this function. So let's see what happens when we console.log the value of b. Look, notice how we didn't need to invoke b as a function. We logged b and we got 2 back. This is exactly the same as if we said something like const c equals 2 and then log c. So the key takeaway here is that when we log the value of b, there's no function involved whatsoever. At this point in the code, from the perspective of the JavaScript engine, b has the value 2. It never had a function assigned to it. And the reason is because of this parentheses here. So what this is doing, this right here is an IIFE. What this is doing is it's telling the JavaScript engine, when you encounter this code, I want you to evaluate what is within these parentheses, evaluate this function, find its return value, and then this entire block of code, replace this with the return value. So by the time the JavaScript engine is ready to run the script, so first it goes through and parses the code and interprets it and ensures that all the syntax is valid, and it basically interprets it beforehand. By the time the code is ready to run, this variable b only has the value 2. So an IIFE is evaluated before the code even runs. So that's why b is not a function. If we tried to call it like a function, we get an error. It says type error, b is not a function. Even though we wrote an anonymous function here because we enclosed it in these parentheses and turned it into an IIFE, it's evaluated before we even have a chance to invoke it as a function, and we get this return value in the place of b. So this lets us achieve some pretty neat behavior. I'm going to comment out this old counter module we wrote, and let's see how we can rewrite this using an IIFE. So we'll write const counter equals, set up an IIFE here. So now we'll write this slightly differently. Let count equals 0, return an object with methods getCount. And this is a function to return the value of count, and increment, which is a function that increments count. So let's look at what we have here. Counter is no longer a simple JavaScript object. It has this IIFE beforehand. And one very important feature about IIFEs is that they create what we call closures. And the closure refers to everything within the function that we sort of lose access to by the time we're ready to work with the return value. Let's just let me just give it a brief demonstration of what this means, what a closure means. So if I write a function, const a equals function, and inside this function we have a variable let zzz equals 999, just for example, some random values. We'll console.log zzz, and then return 2. And now we console.log a. We invoke a as a function and log the output, and run this and see what happens. We get, as output, we get 999 followed by 2. This first 999 comes from this line of code within the function a that's logging the value of zzz. And then it's returning the value 2, which is returned back to this outer console.log statement where we're printing out the return value of a. So, but look what happens when we try to do something like console.log a.zzz. It's undefined. So what's really important to notice here is that this variable zzz, we can access this from within function a, but outside of function a, we have no way of accessing zzz. Now let's change this around a little bit. Instead of returning 2, we're going to return zzz. So now let's run the function a again and see what we get. We get 999. So, but we still can't access zzz normally as an object property. So this is essentially what a closure is. We have the value of zzz enclosed within this function, and the only way we can see its value or modify it is through what we end up returning outside of the function. And this behavior works very well with IIFEs. I'll show you why. So this is sort of what we're setting up here. In the same way that zzz wasn't able to be accessed outside of the function, we're doing the same thing with the IIFE. We're setting up count as a normal function scoped variable inside this IIFE, and we're returning a set of methods that perform operations on count, but we're not returning count itself. So now let's examine this counter module. We'll log, first let's log the value of counter and see what we get. And you'll see we get an object with the methods we specified. Okay, so now let's log the value of counter.getCount, which is our function that gives us back the value of count. We get 0. Console.log count. We don't need to log this actually, we'll just say counter.increment console.log counter.getCount. And we'll log the value of this, and we get 0 and 1, just like we had it initially. But now we try to do that same thing where we go right in and set count to an unpleasant value. We can't, oh, and let's then log it again. It doesn't change it. It doesn't change count, because in these methods that we're using, this count that they are referring to and accessing is safely enclosed within this IIFE, which by the time we're ready to use these functions, we have no more access to aside from the access provided to us by these functions that we have returned out of the IIFE. So essentially, the variable counter takes on the value of what we're returning, but the method specified in this object can still access this enclosed inner variable. So it's like this, it's like we're hiding this value inside the IIFE. And this lets us safely use this module, and we can be assured that this value count will not be modified in unpredictable ways. And that is the power of the IIFE in JavaScript. This pattern is used a lot in many popular libraries. It's actually used in the Node.js module resolving software to import. When you use the require method, this pattern is being used to make sure that variables do not collide with each other. But yeah, this is one of my favorite parts of JavaScript, because when you start using this pattern well, you can achieve some very cool and flexible, clever things with it. So yeah, I wanted to briefly go over this. This has been the module syntax pattern in JavaScript, and I hope you have a wonderful day.